Welcome to homework.
Okay, we've got a poorly named compound and we have to draw it and then figure out the real compound. So I jump right to the end and see cyclohexene, right? 4-cyclohexene. So I'm going to draw cyclohexane. I'm going to make it cyclohexene by adding a double bond. And then I'm going to number one of these carbons 4. This won't be our final numbering scheme, most likely. And then I will go through and number the remaining carbons. Right, so theoretically this should be 5. It could also be 3. If we run into a problem, then we'll number it in the other direction. So 6, 1, 2, 3. And we're told that we have a bromo at position 1. Now I'm reading from the front. At position 4, we have an ethyl, which I will designate as ET. ET equals that, CH2, CH3. And then on carbons 1, we have a methyl. On carbon 2, we have 2 methyls. And on carbon 3, we have a methyl. Yep, and that's it. Now we need to name this basically for real. Like, what's its actual name? So when we've got something besides just an alkane chain, we need to start looking at the substituents, non-carbon substituents or non-alkane substituents, and decide which is the highest priority. Because when it comes to numbering this, we have to assign a numbering system that will make the highest priority substituent have the lowest possible numbering. So in this particular case, the alkene, or the double bond, has the highest priority according to the Kohn-Ingold Prelog rules. Okay, so that's what we're going with. We need to number the ring such that this alkene has the lowest possible number. Now, following that, we obviously have a choice, right? So I'm going to erase this old numbering scheme because it's going to get confusing quick if we leave it up. And I'll put the new one in green. We could make this one, in which case this would be 2, 3, 4, 5, and 6. Or, well, maybe I'll do this in red. We could make this one, in which case this would be 2, 3, 4, 5, and 6, right? Now, to help us decide between this, once we've got the alkene, starting with a 1, either with the green scheme or the red scheme, we need to start considering our other substituents and how we could number them such that the first substituent alphabetically will have the lowest possible number in our numbering scheme, right? So our other substituents are bromo in alphabetical order, methyl, oh, nope, that would be ethyl is next, ethyl, and methyl. And we don't count the T in tetramethyl, right? So technically this is tetramethyl, but we don't include the T for the purposes of alphabetizing it. Okay, so which of these two schemes gives bromo the lowest numbered substituent? Looks like the red scheme does, because in that case, bromo is 4, whereas in the case of the green scheme, bromine would be numbered 5. So I'm going to phone call. I'm going to erase the green scheme so we don't get confused by that. And once we have that erased, we can just start, naming it. Okay. So we know it's going to be for bromo. We just kind of went over that, and maybe not draw that in red. 4 dash bromo dash, and our ethyl now is on 1 dash ethyl. And let's move that out of the way. Okay. And our methyls are on, I see one on 4, 5, 5, and 6. So we do 4, 5, 5, 6 dash. And then we need to do, it's not just methyl, it's tetramethyl. Tetramethyl. And this is one word, so I'm going to try to squeeze this in here. Well, we've got a couple options. We can do, well, I'm going to maybe stick with this cyclo, hex, 1, N, or en, sorry. And I ran out of room. There's an extra E on the end there. Maybe I can drag this over. Give myself a little more space. Yeah, perfect. Okay. En. And the other option would be to say tetramethyl one cyclohexene. I think this one is more valid these days.